You want to start the evaluation of the DAC EV12 DD700? You want to take advantage of its two channels, capable of generating signals from low frequency to Ka band in multiband and simultaneously? You want to benefit of its digital features, enabling unprecedented levels of dynamic RF system and reconfiguration on the fly? You can start evaluating its RF performances and digital enabled capacities by performing a chirp signal generation with our EV12 DD700 FPG EVM and the associated GUI. Here is an overview of the evaluation board giving access to the two DAC RF outputs and the GUI, allowing you to easily configure digital capabilities. In this video, I will give you all the information you need to get started with the EV12 DD700 evaluation board for chirp generation in C-band and in X-band using the graphical user interface. So let's start by setting up all the equipment. The equipment we used are a spectrum analyzer from Rode Schwarz, a Teledyne Lycroid LabMaster, a SMA 100MB from Rode Schwarz, a balloon for clock, that's a Marquis BAL 0020, a balloon for Marquis for signal, that's BAL 0036, the DD700 product board and power supply board, and the PC with the GUI installed. One of the DDS functionalities is a chirp signal generation. The DDS allows the DAC to generate a continuous waveform without data samples sent from a PGA. The chirp signal is a sweep of the sinus pattern generated by the DDS. SPI sequences are used to write configuration register and to start signal generation. Chirp signal parameters are programmable and are illustrated in this chart. What needs to be specified for the chirp is the start and stop frequencies, the frequency step between samples, that's the sweep rate expressed in Hz per second, the reset state, the trigger mode, and the amplitude set by the DDS amplitude parameter. Now that we have a good overview of the chirp feature, let's get started. Power up all equipment. I set the clock frequency to 12 GHz and the output power level to 5 dBm. A balloon is used to provide a differential clock input. Turn on the product board. Turn on the power supply board, then switch the RF on the output signal generator. Power up the DAC using the switch button on the power supply board. Connect the board to the PC using the USB cable, then open the GUI. Now we can start to configure the chirp. In this video, we will perform two configurations. The two DAC outputs in the X-band generating chirp, and the other one is one DAC output in C-band and one DAC output in X-band generating chirp. Here is the step-by-step configuration procedure. Set core analog mux 2, 1, core A and core B to 16. Perform a manual loop alignment using the flat FFT mode. And check that the delay allows the best RF performance. Here, for channel B, the best value of manual delay is 5. Then, for channel A, the best value is 6. In this graph, we can see the output response of the EV12 DD700 for the different modes. Depending on the band you are using, select the appropriate mode. Here, select the RF mode to allow best performance on X band. Set the DDS amplitude to the maximum. Select the chirp enable box. Set the start frequency to 1 GHz. Set the stop frequency to 2 GHz. And set the sweep rate to 10 MHz. We can see the impact of the DDS value on the spectrum. we can see that the level increases and decreases with the DDS value. See the impact of the sweep rate on the spectrum. The sweep rate has an impact on the shape of the output spectrum. Now duplicate this configuration on core A. Now we can visualize two chirp signals, one from core A on the lab master and one from core B on the spectrum analyzer. The Teledyne LeCroy has a signal processing functionality, and we can display time domain and frequency domain equivalent, so we can see both. Set the RF mode to allow the best performance on X-band on core A. Set the NRZ mode to allow best performance on C-band on core B. Set the start frequency to 3.8 GHz. Set the stop frequency to 4.4 GHz. Set the sweep rate to 560 kilo. Now we can visualize two chirp signals, one from core A on the lab master and one from core B on the spectrum analyzer. We have configured a start frequency of 3.8 GHz and a stop frequency of 4.4 GHz. On the spectrum, with the marker, we can see that the start frequency is 3.8 GHz and the stop frequency is 4.39 GHz. We have reached the end of this video. You have learned how to get started with the evaluation board of the EV12 DD700 FPG EVM to generate up to 2 chirp signals in different bands simultaneously. The evaluation board is available so you can start your developments right away. If you have any questions or if you are interested on the evaluation board, please contact us using Teledyne E2V outline email address.